to introduce myself. I'm Paul Robichaux from Dell. Many of you I've met or seen, but there are a lot of people here I don't know because I'm relatively new to the Lync world. I was asked to do this session because a lot of Lync administrators are not deeply familiar with how Exchange Unified Messaging works. And there's an element of mystery and maybe even a little fear associated with it. So my goal in this session is to teach you enough about Exchange UM so that when your Exchange people come to you and say, hey, we want to route Lync calls to Exchange for voicemail, it'll seem like a perfectly reasonable thing for them to ask. So let me start off by asking how many of you have Exchange administration background? Sweet! This is almost the opposite of the session I had yesterday when I did the Better Together 300 level session. I asked the same question. I had a room about this size, I had about the same number of people, and I think I had maybe 2 or 3 hands raised. I was thinking, okay, great. So good. In that case, we ought to be able to get into talking in a little bit more depth about Exchange UM and how it works. How many of you have got UM deployed right now? Even better. Okay, how many of you have got UM deployed on Exchange 2013? Wow. Y'all are some early adopting people, tell you what. Well, good, because those are all things we're going to be talking about today. I'm going to spend some time talking about the framework of the session and what we're going to be covering and what we're, more importantly, not going to be covering, we're not going to be talking about in depth. Then I want to spend some time going on a sort of whirlwind tour of Exchange 2013 UM. Because y'all are all experienced, or many of you, if not all, are experienced UM admins and are familiar with the product, I'm not going to spend as much time in that part of the presentation. Then I'm going to move on to start talking about automated attendance, call answering rules, and call routing with Lync, including some coverage of how you set up hybrid environments where you've got Exchange UM in the cloud and Lync on-prem. Is anybody doing that right now? Okay, is anybody thinking about doing that or wondering whether they could do it? Who's waiting for Lync Business Voice? They only announced it yesterday, so nobody really knows how much longer you're going to have to wait at this point. But I like the idea. Okay, also, because I totally forgot about these in my session yesterday, I have some of these extremely valuable collectible Lync cards. Yes, Lync Basic, or maybe Lync is now Skype Pro. I'm not really sure, but I do have these to give away during the Q&A session. So if you have questions, what I'd like to ask you to do is hold them till the end, and then get on the mic so that for the session recording, your audio will be captured, so that people watching at home or watching later will know what you're asking about. So by way of introduction, it's important to start off by answering a question I was actually asked yesterday, which was, okay, so if I use Exchange UM, do I have to use it with Lync? Well, no, you don't. Exchange is happy to accept calls from any well-behaved, standards-conforming SIP PBX that uses SIP over TCP. Now, the second half of that question was, oh, okay, great. In that case, can I take my Lync calls and send them to some other voicemail system? Well, I wasn't going to touch that one with a 10-foot pole. But the fact of the matter is that Exchange doesn't really care where the calls originate. It is happy to take calls from your junky old Avaya. It's happy to take calls from Nortel, Mitel, ShoreTel, your Momtel. It doesn't care. All right? As long as the call is presented as a SIP invite to Exchange, even if it has to pass through an intermediate gateway, Exchange is happy to accept it. Having said that, there are a lot of other places where Lync and Exchange can tie together. Okay, we talked about some of those in Better Together yesterday. I'm going to be repeating that session this afternoon and talking about those same things again for those of you that missed it. But a lot of those integration points happen at the client. Okay, in this context, what we're most interested in is how do Exchange and Lync on the server side work together for call routing and call answering. Now remember, when we talk about call answering, sort of the end user view of that is my phone rings and I don't answer it, and so Exchange takes the call. And that's true, Exchange does do that. But you also have to keep in mind that Exchange can answer the calls for automated attendant calls, and it can answer calls for, depending on the term you like, some people prefer to call them personal attendants. Some people prefer to just refer to call answering rules. I am not quite ready to start calling them Outlook phone rules or Outlook rules phone edition, but that's a trend that they're going, the direction that those things are headed. So we're going to talk more about that too. When you put Exchange UM together with Lync Enterprise Voice, then that's sort of the pinnacle or the capstone of what Microsoft has to offer in terms of universal communication solutions right now. Because you get all the modalities that Lync makes available, ranging from very simple, low bandwidth text IM all the way up to full-blown multi-party high-res video. In addition, you have Exchange taking calls when you can't and doing some things that complement what Lync does very nicely. But the first thing to remember in that context is what Exchange does. Exchange answers the phone. That's what it does. It doesn't route phone calls. If your Exchange server falls over dead because you spill a Grande Super Decaf into it, Lync still works, phones still ring, they just don't get answered. This is something very common that I hear from customers who are not familiar with or experienced with Exchange. One of their big worries is, oh my God, what happens if I'm using Exchange for voicemail and my Exchange server goes down? Well, what happens right now when your phone rings and nobody answers it? Nobody answers it, right? You're not actually losing a whole lot of functionality in that point. I turn that argument around and say, well, yeah, when you have Exchange answering the phone, you're getting the benefit of this really robust, expensive architecture that you put into place to safeguard your email, right? Where you've got backups of backups, and you have lots of redundancy, you have high availability, you have site resilience, you have administrators who are very skilled in managing Exchange to keep it up. And now, instead of this junky old dust bunny box in your phone closet doing your voicemail that you have to pay maintenance on every year, now that just flows into Exchange. So once it answers the phone, a couple of different things can happen. And that's why, courtesy of Mr. Jamie Stark, I'd like to give him mad props. He was able to arrange this beautiful PPI for me to draw on so that you guys don't have to try to read my scribbles drawn with a mouse. A little later, we're going to talk about the difference in some of these call answering flows between when Exchange answers a phone call for Joe and when it answers a phone call for Joe Industries. Okay? The automated attendant mechanism is basically a pretty sophisticated interactive voice response application that's built on top of UCMA, which means that if you're comfortable developing in UCMA, you can write your own automated attendants that plug into Lync, just like the Exchange team did. Now, that's not a trivial undertaking. I'm not suggesting it's something you'd want to do in a weekend. But when you look at the things that the automated attendant engine and that Outlook Voice Access do, you'll recognize that what Microsoft has done is build an Exchange-themed or Exchange-centric IVR app that uses the same tools that we as platform consumers have access to. So Exchange answers the phone, whether you're calling an individual or the one of the IVR endpoints. It lets you record a message using a couple of different audio codecs. It has the optional ability to take that message and transcribe it into text. Sometimes that's more accurate than others, as y'all have probably seen. It takes the combined voice message and or transcription and puts them into users' mailboxes. So right there, if you stop right there, that's pretty much what Exchange 2007 did, with the exception of the automated attendant stuff. Okay. Exchange 2013 UM does a bunch of additional things, many of which Jake talked about in his session this morning. One of the things that I particularly like to demo is Outlook Voice Access, which gives you the ability not just to get voicemail into your inbox, but to use your telephone to answer your mailbox. How many of you use that regularly? Anybody? That was a lifesaver. I used to live in California, and thank God I'm recovering, and I don't have to do that anymore. But when I lived in California, I had an hour-plus commute every day. So just about the first thing I would do once I maneuvered onto Highway 101 was hit the speed dial button for Outlook Voice Access on my phone and use the Bluetooth in my car to triage my email. I didn't want to use it for heavy-duty email work, but it was really good to be able to say, delete, next message, delete, next message. That way, by the time I got to work, I had gotten rid of all the crap in my inbox, and the only stuff left for me to deal with was mail that actually required me to pay attention. Okay, admittedly, that's a little bit of an edge case, but the fact that Exchange provides this is just one more hook that lets us tie into the inbox, right? The inbox is a source of all this other magical data. How many of you were a little skeptical yesterday when Gurdeep was talking about the predictive stuff that he thinks is going to be coming? I thought it was really interesting that he was predicting predictive behavior, right? Did someone predict that he would predict prediction? I don't know. This is Las Vegas. We ought to be able to find out, right? We ought to be able to get the odds for that. But the fact of the matter is that there's a huge amount of information in your users' Exchange mailboxes. There's information about where they go, what they do, who they talk to the most, who they talk to the least, how they respond to mail, whose mail they do and don't respond to. And all of that data can be intelligently mined by Exchange. We already see that happening in the Lync client. When you, for example, look at someone's contact card and hover, and it says, hey, this person is free until 3 p.m., or they're busy until 5 p.m. Where does that come from? the Exchange calendar. Did the user sit there and say, okay, well, I'm going to put this in so Lync will know? No. She put it in there so she would know where she was going to be and who with and doing what. And Lync was able to extract that data. So being able to give one more channel to users to get that data through OVA is pretty slick. And I'm sorry, I didn't mean to turn this into a philosophical digression about what I think is cool. But on the other hand, you may as well get used to it. The other thing that Exchange does that a lot of people don't think about is that it makes outbound calls also. Right? People don't tend to think about that, but in the context of play on phone, in the context of call answering rules, and in the context of dial by name from an auto attendant, then Exchange has the ability to initiate an outbound phone call. Now that gets really interesting with Lync, because one of the things that Lync does is provide this really rich system of call rules and number management tools that Stali is going to talk about in the session following this one, actually. So if you think about when Exchange places a call, remember, earlier I said it's PBX agnostic. Exchange is going to send out a call request somewhere, and whatever receives that, whether it's Lync or a Mitel box or a PBX that you built yourself using instructions from Make Magazine, that thing is responsible for placing the call, not Exchange. So let's get architectural here for a minute. In 2010, as you all know, it was a separate role. One thing Jake alluded to in his session that I particularly liked, and I'm going to repeat, there's no sizing guidance for servers. There wasn't in 2010. There isn't in 2013. I'm not holding my breath for the next version, quite frankly. The guidance that Microsoft gives people is that even with all these architectural changes, you should still plan on a maximum of about 100 concurrent phone calls per server. So it's real simple for you to look at the number of active ports you have, divide that by 100, and that tells you about how many servers you need just from that one metric. But there are a few other things to keep in mind. And we'll get to that a little bit later. So in 2013, what used to be the separate 2010 role has now been split into multiple parts. Some of those parts ended up on the CAS, and some of them ended up on the mailbox server. Now, I'm going to warn you right now, you will hear me talk about blah, 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 the Exchange 2013 server. I know there's not actually such a thing, but since the product group is now recommending that you put CAS and mailbox on the same server all the time, your CAS server is a mailbox server, is a server. And that's just the way that I tend to think about it. Although technically it is true that you can have these pieces on two different servers, and there are a few design considerations that come into play when you do. In general, it's simpler if you just consider these two to be on the same box. So having said that, let's pretend I didn't say it, and let's talk about the separate pieces. So the CAS in 2013 is a very lightweight proxy and routing role. It doesn't have any stored data. It doesn't queue anything. All it does is accept incoming requests, figure out where they go, and then send those requests someplace else. That's true for message routing. It's true for transport. It's true for So the call router service running on the CAS is going to accept an incoming call request, figure out what mailbox server to send it to, and then redirect it there. It has nothing to do with audio. Okay, that's really important because sometimes when you think about the path that audio has to take to get from a user endpoint to your server, you may be tempted to think that the CAS is somehow stepping in the middle of that transaction, but it's not. All the CAS does, all the call router service does, to be more precise, is accept that request, figure out where it goes, and then send it there. The mailbox server, on the other hand, is much closer to what we would think of as the role in 2010. Because it runs service.exe, it runs a worker process that actually does the work, and it answers the phone. It does audio in both directions. It looks up the user's mailbox and opens it to fetch their recorded greeting, if they have one, and then plays it back. So everything that 2010 did is now done on the mailbox role in 2013. What the 2013 CAS role does, and I keep repeating this, but it's really important, all it does is proxy. Okay? So I'm going to leave it to you to think through what that means in terms of load balancing, for example. But I'll give you a hint. Load balancing is exactly like load balancing every other protocol that goes to the CAS. Because all the CAS is going to do is look at the information that it's presented and then figure out where else to send it. Okay, let's see what happens here. I'm going to kind of stand over here in case the PPI catches on fire. I don't think that's likely, but no, okay. Okay, so we'll keep driving on. For those of you who are listening at home, there is a small chance that you're not going to be able to see my diagram, which will probably improve your life because I have crappy handwriting. Okay, let's talk more architecture. As I mentioned, you can and probably should combine these, but what you'll see if you do that is ping pong. Because the incoming call is still going to go to umcallrouter.exe, and it's going to be SIP redirected to the UM service. So if you're doing a Wireshark trace, you're going to notice these calls bouncing back and forth and back and forth and back and forth between different components and different ports on the same server. That can be a little bit confusing. From a scalability and a topology standpoint, then the discussion's on like a pot of neck bones. I mean, there's all kinds of stuff that you can theorize about scalability, but the bottom line is, if you scale your workload for the amount of mailbox server work that your servers are going to be doing, is just like a noise in that graph, right? It's a little bit of dust on top of the pile. Unless you have a very busy environment where you have a lot of concurrent calls and a lot of voicemail preview, then UM's not going to add a huge amount of load to your mailbox servers. Okay. Now, having said that, well, I'll talk about that later. Voicemail preview is really cool, but you pay the price for using it in terms of performance. So this is a cool diagram that I stole from Ross Smith, but he's not here, so I don't guess he can complain. This shows the flow of these protocols and components and pieces from the clients in the blue stripe up at the top down to the mailbox roll. And so the piece that we're really most interested in is all the way over on the right-hand side, where we have SIP and RTP traffic going to the call router service on the CAS. And then notice what happens. The call router and the service themselves don't talk to each other. Okay, why is that? Well, for those of you that are already familiar with SIP redirects, you'll look at this and go, okay, yeah, that makes sense. If you're not familiar with that, then the basic concept to keep in mind is that when the call router answers a call, it's going to send back a message that says, I'm not the droid you're looking for. You need to reinitiate that call request down here to the mailbox server or to the service on the mailbox roll. And in fact, that's actually what happens, as you'll see in a minute when I have a flow diagram that we can walk through. So this new architecture has some consequences in terms of how you lay your topology out. Probably the biggest change is that any server in a dial plan now can answer any call for any user. Okay, so what that means in most cases is that people will say, hey, great, I don't need multiple dial plans anymore. I'm going to put all my servers in a single dial plan, and they'll all answer each other's calls, and everything will be fine. Now, the one time when that can break down is when you consider that the dial plan is a unit of policy control for Exchange. So, for example, suppose that you want to have voicemail preview in French on a server. The only way to get it is to have that server be part of a dial plan where the default language is French, because the default language on the dial plan controls what language voicemail preview uses to interpret things. Just for fun, I want you to imagine what happens if you have your default language on the dial plan set to French and someone leaves a message in English which voicemail preview then tries to translate. Okay, you essentially get garbage. So that's an argument against just dumping everything into a single dial plan, but for those of you who are not in multinational or multilingual organizations, I think you're probably going to find that's the simplest topology, because it means that your load balancing or load distribution of calls coming out of the PBX gets much simpler. Any call can go to any CAS. Any CAS can route to any mailbox server, and the mailbox server can answer the call and process it from there without you having to do anything to make that happen. So let's talk a little bit about traffic. Okay, I hope you notice these spiffy icons from the template. You can probably figure out which one the Lync server is. And for some reason, we don't have a separate set of icons for the role anymore. I know, I'm not sure why. But this middle, the other thing is that the CAS and mailbox icons are different. Notice that the CAS icon has got the orange Exchange symbol, and the mailbox server has got the approved blue Exchange symbol. Both of these are from the same Microsoft Visio template. So I'm not sure if there's a subtle message that we're supposed to pick up on here or what, but it will help us tell these apart. So if you think about what's happening, Alice is trying to leave a voicemail for Bob. So she's going to place a call, which is going to arrive at Lync, and then a bunch of stuff is going to happen, and Bob will end up with a voicemail in his inbox. So first, let's talk in gross terms about where the traffic goes. So from Lync, we're going to have an outbound SIP request that goes to the call router service on the CAS. And just for simplicity's sake, I'm continuing to pretend that the CAS and mailbox are on two different computers. But this flow is exactly the same if you just scratch out the server icons and just remember that call router exe and service exe are really the players we're talking about. It doesn't matter what physical box they're located on. So Alice's call arrives at Lync, and Lync decides that Bob is not answering or is busy or for whatever reason is in need of a voicemail. So Lync is going to send an invite to the call router. Now this is a little bit misleading where I say SIP or secure SIP on TCP 5060 or 5061. That's not entirely true. Lync will never send an insecure SIP request to Exchange because that's not how Lync rolls. But some other off-brand PBX might use insecure SIP. Exchange doesn't care. It listens on both of those ports if you have your services running in what we call dual mode. So for all of these, you're going to hear me talking about secure and insecure SIP and RTP. Just remember that Lync is always going to secure those with mutual TLS. So the request arrives at the call router, and it sends back a SIP redirect that says, no, wait, I got your call, but I'm not the guy you should be talking to. You need to be talking to this other machine over here. So Lync is then going to initiate another SIP invite, actually to the service on the mailbox role. The worker process is going to send back a SIP 302 moved temporarily header. For those of you that are SIP nerds, you'll know exactly what that means. It's telling the server, hey, you need to temporarily redirect. In other words, don't consider this to be permanent. Consider it to be like an HTTP 451. I want you to temporarily rejigger how you're planning on handling this call. So the the Lync server is then going to initiate SIP traffic back to the worker process, which is going to do all the audio goodness. Okay? And I don't want to, I'm happy to discuss the details in Q&A time or afterwards if you want to talk about the RTP and STP negotiation process. But really, for Exchange purposes, we don't care. Exchange is going to answer the phone, which means it's going to open this channel and do some stuff to get the user's greeting and then play some audio. How that audio gets to the remote end, from an Exchange perspective, we don't really care. Except in the occasional case where there is a firewall or some other, something is blocking this traffic going one way or the other, in which case you'll have symptoms like the user thinks the call is answered, and if they talk, it's recorded, but they don't hear audio from the server, or the caller can hear the server prompts, but no audio makes it back the other way. Dead giveaway when one of those two things happens, that something is interrupting the flow of traffic or the establishment of that audio session. But for our purposes as Exchange people, not our problem. Okay? We refer to that in the consulting industry using an acronym known as SOCP, some other company's problem. All right? It's a very valuable acronym to know. So I stole this table from my book. The formatting is not the best here because it really is a big table with a lot of words. But I put it up here because I wanted to distinguish between ports whose assignments you can change and those which you can't. So if you want to change the ports on which your CAS listens for traffic, you can do that with set call router settings. You might want to do this if you have multiple SIP services coexisting and you want to separate their traffic by port. You may also have some kind of weirdo PBX that you bought on eBay that doesn't use the standard SIP ports and you need to accommodate it. Right? I have seen that happen. People are like, yeah, I got this great PBX and it was only a couple $100. Oh, really? Yeah, some guy's business, his business shut down. He was selling all his stuff on eBay. Right on, man. Recycling, it's the American way. SIP traffic to the mailbox server uses 5062 and 5063, and that you cannot change. Then SIP traffic to the worker process uses a total of 4 ports to let you handle multiple concurrent calls, or the case where the service spins off a new worker, which it will do by default every 7 days. So it can spin off a new worker without terminating the old one until the old one no longer has any calls associated with it. By the way, somebody please remind me when we get to the end of the session if I have time to talk about managed availability and how you use it to control what does. Because people just think, oh, I'll just turn off the service. Well, guess what happens when you do that? Managed availability turns it back on. It's being helpful. All right? So if you have startup mode set to dual, and let me swerve and talk about that for a second. Does everybody understand what I'm talking about when I talk about the startup mode of the services? If not, this would be a good time to dig into that. Anybody want me to talk more about that for 30 seconds or so? Okay. So the services themselves on Exchange can function either using plain SIP or SIP that's secured with TLS. For some reason, the services start up in a mode that will only generate and will only accept unsecured SIP. To talk to Lync at all, you have got to have SIP security enabled. So your choices for the startup mode of these services are to leave them insecure using unencrypted traffic, to require them to use secure traffic only, which is known as secure mode, or to set them to a mode where they can accept either. If you are in a pure Lync environment, it is perfectly okay to set these services to secure mode so that all your traffic is secured. But I don't recommend that you do that. And the reason is that for troubleshooting purposes, it's really handy to be able to send raw unencrypted SIP to Exchange so that you can Wireshark it and you can see what's happening as that traffic flows through your network. Now, making this change is very simple. You use set service with the startup mode switch. So if you want to set it to secure and then only set it to dual when you have troubleshooting to do, that's okay too. Just bear in mind that you have to restart the service for it to pay attention to that change. So it's not something you would normally want to do in the middle of a workday if you have high call volume. Okay, you could sneak it in at the beginning of the day or maybe during lunchtime, but it would be better for troubleshooting purposes to have it be in dual mode all the time. Now, I mentioned earlier that Exchange is basically an IVR application. Well, like most other acronyms, when there's one acronym, they're like roaches or some other ones hidden just out of sight. So before we can talk about some of the specific speech processing things that Exchange does there are a couple more acronyms we have to equip you with. One is ASR. The Exchange documentation uses that to mean automated speech recognition. And all that means is that the computer will hear speech and it will attempt to interpret it. It can do that in the form of people's names. It can do that in the form of simple commands like directory or clear my calendar. Or it can do it in the sense of providing speech recognition. What we normally think of when we think of ASR is dictation, right? You pull your phone out of your pocket, you say, Siri, what's the weather in Philadelphia? Or you push the button and say, Lync, join my next meeting. Was anybody surprised to see that functionality yesterday, by the way, in the keynote? Okay. I had seen it before, but I never get tired of seeing it because it's just freaking cool. Right? When I was a little kid, having a thing that you could hold in your hand and talk to and tell it to do stuff was science fiction, and now we really have it. Living in the future is awesome. We even have shiny Diet Coke. I know. So some of the things that are in Exchange are traditional, what we think of as IVR apps, like the one that you get when you call Delta Airlines. And say your frequent flyer number, or you say reservations or agent, or I'm stuck at the airport and I hate you. All right? Speech recognition people have a certain vocabulary that they use to talk about different kinds of speech recognition. And so voicemail preview is what a speech nerd would refer to as a continuous speaker-independent automated speech recognition system. Continuous means that you don't have to pause. If you think about your interactions with an IVR system, you'll probably say, representative. You have to speak very clearly. Even though some systems are better than others, you're contending against background noise and crappy call quality on PSTN calls. And so the system can't understand you if you say, I need a representative to rebook my flight. That's too many words. On the other hand, what we want is for voicemail preview to be able to handle a stream of words, no matter who the speaker is, without requiring training. So that's all the speaker-independent piece means. Okay, we're pretty much done with the basic architectural stuff. Now we can start talking about some of the more interesting things like how this stuff actually works when calls come in. So for that, I'm going to turn over here to this PPI that Jamie was kind enough to loan me. Sweet. So Alice, let's see, pointer options, pin. Okay, everybody in the front row can see the red dot, so what ought to happen now? All right. There's Alice. Alice is calling Bob. So what happens in a PSTN call? Anybody? Who cares? We don't use a PSTN. So Alice places this call, and some stuff happens. We don't really care what. And the call arrives here at Lync. Okay? I told you all this is 400 level. I warned you. So now the call's at Lync. What is Lync going to do? It's going to ring Bob's endpoints, right? How does that happen? There again, it's magic. We don't care. Bob may have simultaneous ring and call forking turned on. He might, God forbid, be using RCC. We don't know. We don't care. All that we know is Lync is going to try to make Bob's extension ring and his busy light blink. And he will either answer the call or not. If he answers the call, Exchange UM has nothing to do. It is not involved in that transaction at all. On the other hand, if Lync rings that extension or rings that endpoint and Bob does not answer, then Lync is going to send the call to the Exchange CAS, as we discussed earlier. So then the CAS is going to generate a redirect. And this is all SIP. Now, the mailbox server sees this incoming call for Bob's extension. But how does it know it's for Bob? It's got an extension on it. That may be in the form of a SIP URI or maybe an actual telephone extension. But we need a way to tie that to Bob's identity. The way that's done is with Exchange Unified Messaging Proxy Addresses, otherwise known as just EUM proxies. This is just one more address that gets tacked on to the email addresses attribute of the user's object in AD. And it begins just like you've all seen SMTP proxy addresses, right? They start with SMTP : and then the address. When EUM proxy address will say EUM : and then an extension, which can be Bob, right? Think about what a SIP extension looks like. It's just going to be a SIP URI. So his EUM proxy might be bob@contoso.com, or it might be 7714 if that's his extension at the name of some dial plan.contoso.com. I'm going to talk a little bit more about proxy addressing in a minute, but the important thing to keep in mind is that the reason we have this proxy address mechanism is so that when this call with an extension comes in here, using the diversion header, the mailbox server can look at the information in the diversion header and figure out how to route that call to the mailbox server that has Bob's mailbox on it. Why does it need to do that? Well, the greeting that Bob has recorded that says, "Hi, this is Bob Smith from Contoso Corporation. Thanks for your call. I'm at a Lync conference, probably passed out somewhere. Leave me a message and I'll call you back." That greeting has got to come out of Bob's mailbox, and the only way that this mailbox server knows where Bob's mailbox is to go ask Active Directory. Well, the only way that it can figure out what to ask Active Directory for is to have an indexed attribute that it can query. So let's draw another mailbox server over here. And a domain controller. And then you start to see that this flow gets a little richer than what we talked about earlier, just with the SIP traffic going back and forth. This mailbox server will query AD for an EUM proxy, and it will get that back, and then it will make a request using MAPI to get Bob's actual mailbox. Now remember, it's not required. Bob may not have recorded a greeting. There are 3 different greeting states that UM can use. One is the full greeting, where you record it yourself. The second is an abbreviated greeting, where you just record your name, and when a caller calls, they say, "You've reached the mailbox of Bob Smith," or whatever. The third is that the system generates a greeting by trying to turn a name like Paul Robichaux, or I'm trying to think of a really good unpronounceable name, but then I wouldn't be able to pronounce it, so that's not going to work. So the system will do its best using text-to-speech to try to pronounce it, to indicate to the caller whose mailbox they're talking to. Assuming that there is an audio greeting of some kind here, it will be fetched from Bob's mailbox. And then this guy, remember he's the one who answered the call, is going to turn that back into RTP and play it back through the PBX to the caller. At that point, the caller has to make a decision. Is she going to hang up or is she going to leave a message? So show of hands, who wants Alice to leave a message? Who wants her to hang up? Who wants her to take her phone and put it in the slingshot on the exhibit floor? That was awesome, by the way. I've never seen that done at a show before, and it's going to be really hard for the exchange team to meet that bar with whatever they do on the exhibit floor. We might have to go hunt for live pigs from a helicopter or something to catch up. Because honest to God, I'm not kidding, that is a thing in Texas. You can hire a company that will fly you in a helicopter while you hang out the door with a rifle hunting for feral pigs. Because those pigs are, number one, they're really hard to kill, they're really mean, and they tear up crops. So everybody's happy. You get the experience of flying around in a helicopter pretending that you're a sniper. The farmers get the pigs off their land, and the helicopter company makes a bunch of money. It's perfect. America. So maybe that's what we'll do instead of just smashing phones. I don't know. I'm definitely going to suggest that. I'm sorry, now I got distracted. I'm thinking, man, wild pig hunting. Yeah, let's go. Okay, moving right along. So the RTP is going to come back here. Damn it. Apparently I have the death touch on my left hand. I'm going to have to tuck it in my belt or something so I don't touch the PPI with it again. So if Alice leaves a message, then the system, after it plays Bob's greeting, is going to play some noise. And I say that, or stuffing maybe, fluff is a better word. Please leave a message after the beep, and then it'll play the beep. And it may play a comfort tone, right, which is a little doot, 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 doot noise that IVR systems make when they want you to know that they haven't hung up, they're still there, but they're thinking about something or they're waiting for something. So if Alice leaves a message, her audio goes back through the blob to Lync, back here to the mailbox server, which then records it using the selected codec, optionally transcribes it with voicemail preview, and ends up delivering it through the transport mechanism. And I should have... So we've got MAPI traffic to get Bob's greeting, but then we also have SMTP traffic to deliver the message to Bob's mailbox. Now the cool thing is, because this is just SMTP, everything you know about the Exchange Transport System for regular messages applies to voice messages. Protected voicemail protects them with IRM. They flow through the transport system the same way. They're subject to the same safety net. They go through the dumpster. Everything happens with voice messages just as it does with regular messages. So the good news is, if you already know how to troubleshoot Exchange Transport, there's nothing that can happen to a voicemail message that will elude your skills. You'll be like a cross between Perry Mason and Columbo and Sherlock. Right? Wherever that message goes, you can find it because it's just SMTP at this point. Now, if Alice doesn't leave a message, who knows what happens then? Missed call notification, right? Think about what happens if you make a Lync call to somebody and you don't have Exchange UM. They get a missed conversation icon in the Lync client that says, hey, somebody tried to contact you and you didn't answer them because you weren't there or because you didn't want to talk to them. So the same thing happens in this case, except that at some point between the time, notice hovering, not touching, at some point between the time Exchange started playing the greeting and the time Alice completed recording her message, the call was terminated, probably because she hung up. In that case, Exchange will generate an MCN and send it through the same SMTP channel so that it shows up in the user's inbox. Now, part of what happens in this process is that MAPI properties get stamped on the message to indicate that it's either a voicemail or an MCN. That's why Outlook can show the distinctive little icon to indicate that it's a voice message. There's all kinds of nifty transport stuff you can do with transport rules by looking at that property. And one thing a lot of people don't realize or don't think through, you also can make compliance decisions about voicemails based on those properties. So if you don't want to retain voicemails, or if you want to have different retention policies for voicemail messages, you can. I see a lot of customers who ask for that because right now, on their crappy 1975 voicemail system, they have no retention. You know why? Because they have like a 200 megabyte disk drive for the entire organization, and they don't have room to keep voicemail for longer than 3 days or 5 days anyway. Well, all of a sudden now we're moving to a world where you've got a 5 gig mailbox for everybody in your organization, from the guy who sweeps the floors up to the lady who runs the company. Then there are customers who say, wait, I don't want my voicemail to be retained. Fine, turn it off then. Okay, that's a topic for another discussion. We can have a long conversation about things that people say they want to do with UM that turn out to be really simple to do. And, oh, okay, great. Well, let me talk about this other problem that I think UM has. No, I can solve that one too. Okay, I'm trying to think about what else I want to talk about from a call answering flow standpoint between Alice and Bob. This is really it. Now, if I wanted to, I could scratch out Bob and replace this with the Contoso Inc. automated attendant or with Outlook voice access, because the process is the same. The same flow of the call going from the originator through something to the PBX to the target is all the same. One difference is that when we're calling the automated attendant, we don't have to look up the target mailbox because there isn't one. Okay, and I just realized I should have talked about something that I hadn't talked about before. How many of you know what the diversion header is in Exchange UM and what it's for? Anybody not know that? It's worth talking about for a minute if you're not familiar with it. All right, cool. I appreciate your willingness to let me talk about stuff that I should have put in the deck and forgot about. So, most of the time in a PBX system, the PBX already knows why the call is going to voicemail. It was because the called party didn't answer, or because their phone was busy, or because there was an explicit route that sent it there. Exchange doesn't have any way to know that. Why? Because we're PBX agnostic. So we're not using any PBX vendor's API or looking at their QSIG packets or anything to see why this data is or why this call is coming to us, right? So what we get instead is we get an actual SIP header called diversion, and that indicates where the call is really coming from. In other words, the extension of the thing that originated it, along with the extension that it's supposed to be going to. So for example, when I get home, because I love Amazon.com, I will have 2 Amazon packages waiting on my doorstep tomorrow. They have a header on them that indicates that Amazon shipped them straight to me. On the other hand, suppose that the UPS driver knew I wasn't home because he stalks me, and he took those packages and left them at my neighbor's house. What's he going to do? He's going to put a sticker on my door that says your packages were left next door. That's a diversion header. It tells me where the packages originally came from, where they went now, and who they were originally to. So when Exchange gets a diversion header, let me just make this number up, and let's say, come on, Ben. Let's say that the pilot extension on the PBX is 7,000, and let's say that Bob's extension is 9,000, and let's say that Alice's number is 256-555-1212. So when the call arrives here to be answered, there will be a diversion header that says the call is from 256-555-1212. It was originally to extension 9,000, but it's coming from extension 7,000. So that target extension in the diversion header is what Exchange uses to match the EUM proxy. So it's going to be looking for an EUM proxy address that begins 9,000 at something. Okay, does that make sense to everybody? When we're doing a call to an automated attendant, we don't have to do that because the target extension is the number of the attendant. We don't have a mailbox associated with it that we have to mess with. Same thing is true for Outlook voice access. All this stuff that happens to the left side of the server remains the same. The audio flow, the negotiation, the redirect, those are all as they are for answering an individual mailbox call. The difference is in what happens over here. So for an automated attendant, let's see if I have a place to squeeze in an AA object. So in this case, the call will arrive at the CAS. The CAS will send a redirect to Lync. Lync will initiate a call to the mailbox server. The mailbox server will see that the target of the call is an automated attendant, and it's going to load the automated attendant prompt, open up an RTP session, and start playing that prompt back. So the mechanism is exactly the same. It's just where that prompt data gets fetched from and what the caller hears when she goes through it. Okay, so with that said, now let's talk for a minute about addressing. I've already mentioned the guts of what you need to know about proxy addresses. Key thing to remember here is that this is an indexed AD attribute. Okay, so searching for it is very efficient. It's not going to generate a huge amount of additional load on your domain controllers. And I threw an example in here so you can get a sense of what it looks like when you look at all the proxy addresses for a set of users who are both mailbox enabled and also UM enabled. As you can see here, my Discovery Search mailbox doesn't have an EUM proxy address. Administrator doesn't have one. But Colt, Browning, Earhart, Remington, Oakley, Barton, and Stanton all have them because they're all UM enabled. And so each of their addresses is of the form EUM, a phone number, and then a phone context. The phone context is just the name of an Exchange dial plan or a Lync dial plan. Okay, doesn't matter which. Again, Exchange doesn't care. The only thing it's looking for here is when I receive a diversion header, I need to know what extension to look for to use as a match. Okay? Now, with that said, we can talk about some of the other objects that are interesting from a perspective of Lync integration. The first is a dial plan. That's a little weird if you're an experienced Lync person. You tend to think of dial plans as being something that controls how calls are made. They control that in Exchange too, but the Exchange dial plan also sets the default language that we use. It gives us a container to associate automated attendance with. It contains a bunch of other settings that apply to call answering, call behavior. I'm not going to enumerate those because for our purposes at this level, we don't really care. That's how you control the behavior of Exchange The interesting piece is how that dial plan integrates with Lync dial plans to let you place calls back and forth. On the Lync side, a dial plan is a container that has a bunch of normalization rules that let you control how numbers are reformatted both for inbound and outbound calling. So in terms of the correspondence of these two things, they have the same name. They're both called dial plans, but they have very little in common from a functional perspective. I want to make sure everybody understands that before we go any further, because when I talk about dial plan this, dial plan that, if you're thinking of Exchange dial plans as being the same as Lync, you'll be confused, and if you think of Lync dial plans as being the same as Exchange, you'll be disappointed. So in legacy versions, this is a big takeaway. In legacy versions of Exchange and Lync, you had to have a dial plan on the Lync side that had the same name as each dial plan on the Exchange side. That's no longer the case. Okay, because now in Exchange and Lync 2013, we now have an Exchange call router object that's smart enough to figure out dial plan correspondence and handle calls accordingly. So we don't have this requirement any longer. You can have one dial plan on the Exchange side that has all your servers in it, and however many dial plans you need on the Lync side for your actual phone topology. And they will automatically be matched without you having to do anything. Now, speaking of things that are legacy, but that are still with us, we also have this Exchange UC util script, which some of you may have run across before. You still have to use it. And the reason you have to use it is because it does three things that we care about a lot. The first is that it creates IP gateway objects. Now, I wasn't sure how many people in here had experience, so the reason it says, hey, what's a IP gateway? Glad you asked. Was to give me a pivot to talk about it in case anybody wants to know what that is or isn't familiar with that term. It creates hunt groups, which are essentially container objects that have no real reason to continue to exist. They don't really do anything now, but we have them because we had them in previous versions, and we had them in previous versions because they map to hunt groups that you have defined on a physical legacy PBX. I can see into the future, and I'll put on my Gurdeep hat and predict that in another release or two, we may not have a need for hunt group objects anymore, since they're like earlobes, right? They don't really have any function except to be decorative. The other thing that this script does that's really, really, really important, you can create your own hunt groups, you can create your own IP gateways, but Lync also needs read permission on these objects in AD. And if you try to manipulate those AD ACLs yourself, you're probably going to screw it up, okay? Because they're already complicated, they have a lot of terms, they have a lot of ACE entries in them. So your best bet is to run the script and let it do its thing. There's another script on the Lync side that you may sometimes have to run if you are using automated attendance, and I'm going to talk about those now. So how many of you have automated attendance deployed in your environment right now? Sweet, so I can pretty much skip over like the next several slides and just say you already know all about automated attendance. Because you do. If you're already using them, you know that they're tree-based. Press or say 1, press or say 2. Right? You know that they're customizable. You know that you can have multiple options for holidays, business and non-business hours, and so on. Okay? From a functionality perspective, these things are very straightforward. They're just trees. So when you transfer a call to an automated attendant, what's going to happen is that Exchange is going to play the prompt at the head of the automated attendant. Right? And then the user is going to say or press something, and that's going to cause a branch to something else. Now, your branch options are to go to another automated attendant, to transfer to an extension, to do a couple of other things that you're probably already familiar with. One of the most common questions I get is, okay, if I want to make a really complicated automated attendant that replicates the complicated auto attendant we have right now, how do we do it? And my answer will typically be, don't. Don't make a complicated auto attendant. How many of you have seen the DirecTV commercials? Right? When you get bored, you go hang gliding and your dad ends up getting punched, right? So we could make a DirecTV commercial that says, when you make a complicated auto attendant, blah, 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 your customers get pissed off and they stop calling you. That's what it boils down to. The other common question I get where the answer is please don't is how can I make Exchange UM act like my existing legacy voicemail and have the same key presses? Number one, you can't. But number two, you shouldn't even if you could. Right? I'm sorry, I'm getting into philosophy and religion again instead of sticking to technical matters. So make your auto attendants simple. Write the scripts out ahead of time. Have somebody role play them if you want to. You never want to make an automated attendant that will just piss people off because that's bad for everybody. Okay? Thus endeth the sermon. The automated attendants themselves are stored in the configuration naming context. Because really, when you think about what they are, they're tables that map something that the system can say or a prompt it can play with a choice that the user can make. Right? So because they're in the configuration naming context, they are visible to every UM server in your organization. But they're assigned to a specific dial plan. So when you create a dial plan and open its properties in EAC or manipulate its properties with EMS, you'll see that there are some dial plans that are tied to that. Sorry, there are some automated attendants. There can be some automated attendants that are tied to that dial plan. If what you want is to have one set of automated attendants that works the same way for every caller on every server, you'll put all your servers in one dial plan. On the other hand, if you want to have one set of automated attendant behavior for users who call one of your servers in North America and a different set for users who call a server in the Pacific Rim, let's say, one way that you could do that is to put those servers in different dial plans and assign different automated attendants to them. Another really common way is you put all the servers in one dial plan and your primary auto attendant says press 1 for English and then whatever the equivalent of press 2 for Japanese is. And then when they get that prompt, if they press 1, they branch to another auto attendant that's all in English. If they press 2, they branch to a different auto attendant that's all in Japanese. But either way, whichever of those approaches you take, all the automated attendants, even though they're globally visible, are only available to servers that are in a particular dial plan. So what's in an automated attendant? First, a language binding. And we need that for two reasons. One is because we have to tell the system what language to generate text in when the system says something. Okay, for example, if you set a business location in the automated attendant field, the system is going to synthesize that using text-to-speech in whatever language you've specified as a language for that automated attendant. But it also needs that language binding so it can recognize what the caller is saying using one language. Okay? Much as we would like to, this is not Star Trek. We don't have a computer that can automatically recognize any of the supported languages and correctly translate what it hears. I can barely do that. Right? I have a hard enough time when I go to New England, and I like to think that I speak good English, but I don't know. Maybe it's just me. We have custom prompts, which are just recorded audio that you've associated with the automated attendant. That say things like, thanks for calling Contoso, we're closed because our facility got flooded last week. Or thank you for calling Bennington College. The college is closed for holiday break between December 16th and January 5th. Please leave a message or say the name of the person you want to leave a message for. Holiday, business, and non-business hours, these are just bitmaps that indicate when you've told the automated attendant that it should play the holiday greeting, the business hours greeting, or the non-business hours greeting. Those are your three choices. Okay, you can't have holiday business hours and holiday non-business. And the granularity is fairly limited. Okay, this is something that I expect might be enhanced in future releases to give us a few more choices. But for right now, what we have is still decent. You can say, okay, business hours are 8 to 5, Monday through Friday. Play greeting A. During non-business hours, play greeting B. When it's a holiday, play greeting C. That's good enough for the vast majority of what people want to do with these automated attendants. The other thing that's included are key mappings. This is an action table that says, okay, if the user presses or says this, then do that. You'll see something very similar to these key mappings, by the way, when you look at the guts of what's in a call answering rule, which we're going to talk about in a few minutes. Other than that, given that you guys already are all using automated attendants, I don't really think there's any value in me showing you how to set them up because you pretty much have all already done it. If you want to know how to do it, come up and see me afterwards, or we can go to the hands-on lab and you can experiment with it there. Instead, I want to take some time and talk about languages because this is an area where a lot of people on the Lync side are not real clear on exactly what Exchange does and how it works in a multilingual environment. So Exchange has what we call language packs. And the language pack itself is made up of 3 pieces. An acoustic model, which is what does the language sound like. If I suddenly started speaking German right now, number one, it would be a miracle because I speak French and a little Spanish, but no German. But number two, you would probably be able to figure out what I was saying. Sorry, you wouldn't be able to figure out what I was saying, but you'd probably think, hey, that sounds kind of like German or maybe Dutch, right? If I started speaking Chinese, you might not be able to identify the dialect I was speaking, but you could probably figure out that I was speaking something that was not German or English or French or Spanish, right? So that acoustic model is what the system uses to know what sounds does this language have that make it distinct from other languages. The statistical model, remember yesterday when Gurdeep was talking about Bayesian modeling and Bayesian statistical filtering? If I say, the weather in Las Vegas today is blank, you could all finish that sentence. You might say sunny, you might say gorgeous, you might say warmer than back home, you're probably not going to say pizza, right? We all have this sort of built-in statistical model that tells us, based on what somebody just said, what should I expect to hear next? That's why sometimes when somebody says something that's just off the hook, you're like, wait, say that again? Did you really just say what I thought you said? Because our statistical model is leading us to kind of predict what's going to come next, and sometimes that's not right. We have that same problem, by the way, with voicemail preview. I'll talk about that a little bit later. Then there are the prompts and the grammar. Okay, this is the part that humans generate so that when you call an Exchange server whose dial plan language is set to French, you get French audio prompts. Okay, if you call one that's set to German, you get German audio prompts. Somebody at Microsoft records those and bundles them in the language pack, and away we go. Notice that Exchange does not have what we would consider to be a dictation model, so it doesn't understand the way that you would dictate to Dragon Dictate or Windows Dictate or dictation in iOS. Okay, that's just the way that it is. These language packs are used all over the place. I just noticed how far along I am in my presentation and what time it is, so I'm going to pick up the pace a little bit here, guys. The prompts and the grammar are customized for each language. You don't normally touch them, but you can record your own custom prompts for some parts of the system. Every prompt that Exchange uses, every audio prompt is just a WAV file. So, although it's unsupported, if you really, really, really want to, I had a customer in Turkey who insisted that they wanted a Turkish language experience. Well, Microsoft doesn't support that language. You'll see why in a minute. But these guys were able to go through and replace every WAV file so that everything that the system played had been recorded in Turkish. Not a great idea, but they did it anyway. The customer's always right? Nod your head. Yeah. I see a lot of people refusing to nod their heads. So we have, I think, 26 languages. The key languages, the ones that are most interesting from a language pack perspective, are the ones that are supported for voicemail preview. And when you look at this list, it looks a little funny, doesn't it? There are some languages that an awful lot of people in the world speak that are not on here. How many people in the world speak Portuguese as it's spoken in Portugal, as opposed to Brazilian Portuguese? How many people in the world speak Polish or Italian compared to other languages? Well, it turns out that if you model what a good job, or what the percentage of accuracy for recognition is, and then use a standard Likert scale like we use for Lync call quality, if you look at the languages that are in the bubble, those are the languages that people thought were good enough to use. And when I say people, the test users who tested these languages. There are a few other languages that are right on the bubble, like Mexican Spanish, ESMX. Microsoft could maybe, 3.5 is right at the margin of what I would consider to be usable. But there are a bunch of other languages like Canadian French. For some reason, its recognition accuracy is poor, and as a result, people thought it was a terrible language implementation. They didn't want to use it. So it takes an awful lot of data to generate enough statistical model data to get these numbers up. It's hundreds and hundreds of hours to get even a minor percentage increase in quality. So if there's a language that you're looking for and asking yourself, why isn't it there? The answer is either because there's not a big enough market for it, or there's not enough language data for it, for Microsoft to be able to generate a usable language file. I mentioned earlier that the dial plan language setting has a big impact on how your Exchange server interacts with callers. And that's because that language controls what language is used for voicemail preview, what language Outlook Voice Access uses when it's managing prompts, and what language text-to-speech prompts are in. So as I said before, if you really want to see something funny, switch the dial plan language and listen to the voicemail preview messages you get that will be transcribed in the wrong language. Or you could just use Google Voice and you'll get pretty much the same experience. Okay, moving right along. So call answering is sort of the big enchilada. That's why people buy Exchange Unified Messaging. They want the phone answered. They want to be able to have messages delivered to recipients. If you've used Outlook rules, then you know how powerful they are, because they give every user the ability to tailor her inbox experience to get exactly what she wants. Maybe she wants messages from her boss to come in read, marked high priority, and always at the top of the inbox. Maybe she wants messages from her kids to be automatically put in a separate folder. Whatever you want to do with Outlook rules, you can do on your own without having to involve your system administrator. You don't have to go to the Exchange admin and say, hey, can you write me a rule that will take all my messages that I'm CC'd on and put them somewhere? No, you can do that yourself. But with just Lync alone, we don't have a way to do that, do we? We have response groups, which have some call routing functionality that can be user-based, but the users can't do that themselves, right? So what call answering rules or personal attendance give us is a way to take some of the functionality we get for automated attendance and push that down to individual users so that they can make their own calls. So they can choose how to handle their own calls. Jake does a really good demo that steps through this in some detail. Are you repeating your session, Jake, or was it just a one-shot? Okay. I would encourage you strongly, if you want to see a really detailed demo of how this works and how you set it up, I would encourage you to go see that, or to watch his recording from yesterday if you have a conflict. But the basic idea behind call answering rules is to give users the ability to set up what happens with their phones the same way that they can with using Outlook rules to control what happens with their email. So you can set rules that will say, find me or don't find me, depending on my calendar status. Do special things based on whether someone is in my contacts folder, in my gal, or is a specific person. Or to do things based on the time of day. So for example, I can create a rule that says, if at any time any of my children call me, then ring my cell phone number and try to find me. I can have a separate rule that says, if at any time my mom calls me, ring my cell phone and try to find me. If at any time my ex-wife tries to call me, send her straight to voicemail. I'm just saying it's a theoretical possibility, only because Dell has not implemented this yet. But when they do, boy, can't wait. The idea is that you ought to be able to push down the decisions about call routing for individual users to the individual users, with one exception. Okay, I'm going to talk about that in a minute. So each user can have up to 9 rules. They're strictly in priority order. So when you look in the Exchange control panel at the rules for a user, the first one will be the first one that's tested. As soon as the system finds a match of condition, then it's going to apply that rule. So the order actually does matter a lot. In the same way that if you have an Outlook rule that doesn't say stop processing rules, you may have more than one rule executed on the same message. Sometimes that's what you want. Sometimes it's not. So 9 rules, each one of which has one or more conditions, a greeting that gets played, and then an action that should be triggered when the user makes that choice or when that rule is applied. So to show you a very simple screenshot of what this looks like, I can create a rule called Find Me. And it says if the caller is Amelia Earhart or Annie Oakley or Clara Barton or Eli Remington, then let them either press pound to leave a voice message or press 1 to find me. So when they call in, Exchange is going to look at the calling line ID that comes from the PBX, right? And we are not going to talk at all about caller ID resolution because that's probably like 2 of these sessions back-to-back worth of stuff. But assuming that Lync does the right thing and delivers the correct caller ID to Exchange, Exchange can look at it and go, oh, okay, it's Eli Remington. Well, in that case, I'm going to play these 2 prompts, press pound to leave a voice message or press 1 to find me. Notice the reason that these are in quotes is because this is exactly what the system is going to say in whatever language is set on the dial plan. So when this rule fires, if Wild Bill Cody calls, he's not on the list of the caller is, so he's going to get the default experience. It's going to play my greeting, and he's going to be able to leave me a voice message or hang up. He doesn't get find me. He doesn't get any of the other actions that I may have associated with this rule. So by default, when you deploy or when you activate a new mailbox, nothing happens. Right? There are no call answering rules defined, so there's no special call answering behavior. Once you start defining rules, those rules will be evaluated in precedence order, as I mentioned. For conditions, we can make decisions about who the caller is, what time of day it is when they call. In other words, is it working hours, non-working hours, or a specific range of time? And this is another cool integration point. These times are driven by what you set the working hours for on your mailbox using Outlook. So if I say my working hours are 8 to 8, and you say your working hours are 10 to 6, then your rule may be executed differently than mine, even if the conditions are the same. If it says during working hours, you have different working hours than I do, that rule may fire or not fire differently on our two respective mailboxes. Am I busy, free, out of office? And which number did the call come in on? So if you have multiple extensions assigned to somebody like your CEO, you can have one rule that fires when someone calls his public number that everybody has, and you can have a different set of rules that fire when someone calls the secret number that rings directly to his desk without going through his assistant first. What if you want to have a rule that always fires? There are two cases when this is really handy. One is what I call the told to go away rule, right? That's typically when you have an extension that you use for outbound calling that you don't want to accept voicemail. The other is when you have employees who have left the company and you don't decommission their extensions. You want an announcement that says, you've reached an extension at Contoso that belongs to someone who's left the company. Please dial 555-1212 and ask for the operator for more details, or something along those lines. You don't want people leaving voicemails for this person now that they've left because there won't be anybody there to read them. So in either of those cases, you can create a rule that has no condition, and that rule will always fire. So whatever action you associate with the rule will always be taken on any incoming call. Now, speaking of actions, right now we only get 3. You can let the user find me, you can initiate a call transfer to another extension or another number, or you can let the caller leave a voicemail. There actually is another action, which is that if you don't specify an action, the rule will play a greeting and then hang up, which is an action itself. This is an area where I hope the Exchange team will add more actions in the future. I would like to see some additional things added that integrate with my presence status, for example. Maybe if I get a call, I don't know, we could theorize all day long about different things that they could do. But I'm hoping that these rules are going to sprout some more capabilities to make them more like what can be done with Outlook rules. Okay, I mentioned before, if you have a rule that doesn't have an action, if you've recorded a prompt, will play the prompt and then hang up. Otherwise, it'll play a prompt that says, you've reached the mailbox of Paul Robichaux, please call back later, click. So a couple things you can do with that. One is you can use it to add numbers to a list that can never interrupt you. Because when they call, Exchange automatically, doesn't even ring your phone, Exchange automatically plays that prompt and then hangs up on them. Okay. The other thing you can do is you can use this for announcements. So you could record a custom prompt and tell everybody in the company, if you want to know whether we're open on a particular day because of inclement weather, then dial 555-9000. They'll get that. Hey, this is a Contoso severe weather line. Today, February 20th, we are open. Have a nice day. Click. How many of you have seen the Lego movie, by the way? Okay, if you haven't, you should. But probably not while you're in Vegas because there are other better things to do. One of the cool things about call answering rules is that you can script them. This is really handy in two contexts. One is when you want everybody to have the same experience on their phone. So maybe you want everybody in the sales department to offer the same options to their callers. You can ask people to set these things up manually, or you can script it for them. Does that sound like anything in Lync? Yeah, it kind of sounds like a response group, doesn't it? Except that here, the granularity is at the user. You don't have to create a response group. You don't have to do any of the response group administrative stuff to make this happen. You run new call answering rule and apply that rule to the mailboxes, and off you go. Rules are stored as FAIs in the user's mailbox. So when you move their mailbox from one database to another, when you move that database between servers, when you move their mailbox to Office 365, those rules go along with, okay, which is kind of nice. It means you don't have to remove and recreate them. If you disable the user, the rules stay there. So when you enable them again, the rules come back. So this is just a quick example that I knocked out that says, hey, if the user's calendar says that they're out of office, don't let them leave a message. Just play the prompt that says, notice there are no conditions, or sorry, there are no actions specified. So it says if their schedule status is out of office, play the prompt that says, you've reached the mailbox of Paul Robichaux, please call back later, goodbye. Would you actually want to do that so that when customers called, they got this? Hell no. But it illustrates the principle. So when do you use these? Well, two most common cases I see are, number one, when you want to use a routing group service, but you don't, when that's too much, right? When you don't need all the capabilities that RGS gives. The other is that there are PBX vendors who sell add-ons for their PBX that do exactly this, that allow users to have selective find me control. You can quit paying your PBX vendor to do that and implement it using call answering rules instead. All right, let's talk a little bit about call routing. So I mentioned earlier that Exchange can place outbound calls. It can do that in three ways. First of all, does everybody here know the difference between a supervised and a blind transfer? Okay, I see a few people shaking their heads. A blind transfer is like throwing a message written on a paper airplane out the window. You throw it, you fire it, you forget it. You don't have any way to see whether that message got where you wanted it to go. UDP, right? A supervised transfer is one where you initiate the call transfer and you wait to see whether it was successful or not before you drop off the call. Okay? That's more like an introduction. It doesn't quite fit the TCP model, but as an alternative to a blind transfer where you just shove it out the door and then you're gone, everybody can probably see that distinction. Then Exchange can also make plain calls. They're just an outbound call, just like you would make if you picked up your phone and started dialing it. So plain calls are for play on phone, in which case just makes a SIP invite to the PBX, or sorry, the IP gateway that's defined, to place the outbound call. And then it plays audio over that call. A supervised transfer is what we use when we've got a find me and a call answering rule, and blind transfers are used everywhere else. The problem with a blind transfer is that Exchange has no way to tell whether that transfer succeeded or not. So you can sometimes get behavior where Exchange thinks the call was transferred successfully, but it got dropped or blocked, and then the call doesn't go through, and you have to try to figure out why. Bless you. The mechanism for supervised transfers is worth talking about real quick, because it's implemented differently than you might expect. So imagine that you're calling in and you get a call answering rule fired that says press 1 to find me. So you press 1. What's going to happen then? Well, in that specific case, is going to record the caller's name, and then it's going to play a comfort tone to the person who called. So while I've got the phone up to my ear, I'm hearing Exchange go doot, 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 doot. Meanwhile, the worker process has sent a SIP invite out through the PBX. It's placing a call to whatever number I've defined in the call answering rule. If that is answered, either by a human or by voicemail, then it's going to play a prompt. It's going to say, you have an incoming call from whatever was recorded in step 1. Press 1 to accept it. Now, here's the slick part. If the server is playing that audio to somebody's voicemail, they're not going to be able to press 1, obviously. So will decide, oh wait, there's not really a person on the other end, and the supervised transfer will be considered to fail. On the other hand, if a human answers the phone, if I pick up the phone and say hello, it says, this is Microsoft Exchange calling with a call from Michael Pristula, press 1 to accept it. When I press 1, then the system is going to send a SIP refer with headers to the IP gateway, or PBX, that tells it to send that call directly to my number. Okay, so when you think about what happens, Exchange is going to drop out of the call conversation at the point when it knows that the recipient has accepted that transfer. Play on phone, on the other hand, is a great example of a pure outbound call. So when you use play on phone, typically the use case is you have a voice message and you want to listen to it, but you don't have a way to listen to it privately. So you need to use your phone instead of the speakers on your desktop, or you're someplace where there is no audio capability on your computer and you need to listen to the message. So here, when you click the Play on Phone button in Outlook or OWA, you're prompted to put in a phone number. When the call doesn't go through, people are going to make the assumption that the call didn't go through because Exchange is broken somehow. But when you think about what has to actually happen for that call to be completed, Exchange has got to be allowed to place the outbound call, which means that the dial plan restrictions on Exchange have to allow that call to be made. Then, Lync has to allow that outbound call to go from Exchange out through Lync to the outside world. And, this is the one that almost always is at fault, the user has to put in the correct phone number in the first place. So think about it for a second. You're in a hotel room in Paris. I want you to imagine you've got a basket of chocolate croissants in front of you. Right? You're looking out at the Eiffel Tower. Right? Guy de Maupassant, the French author, had lunch every day in the Eiffel Tower. You guys know why? He said it was so ugly that eating lunch there was the only way that he could avoid having his meal spoiled by catching sight of it. So you're looking at the Eiffel Tower thinking, man, de Maupassant, he was crazy. And you have a play on phone situation. So you click play on phone, and you put in what you think is the number of the phone that's on your desk at your hotel. Well, guess what? If you get the country code or the region code or the phone number wrong, that call is not going to go through, even if all your dialing rules are squared away. So what I always tell people who complain or who trouble ticket me or say my users are having trouble with this feature, first thing is, if you pick up your own phone and dial that number, does the call go through? If the answer is no, guess what? It's not an Exchange or Lync problem. It's a user problem. If the call goes through, then I might say, okay, what happens if you dial a different number using Play on Phone? So same environment, if I click Play on Phone and put in the number of my desk phone back in Huntsville, does the phone there ring? In other words, is it a problem with the Play on Phone infrastructure of call transfer and call origination, or is it a problem with something about dialing rules that's making that call get interrupted along the way? Okay, I promised I was going to talk about hybrid, and I am, but not in the way that you might think. So we have a range of different hybrid topologies that we can implement with Exchange and Lync. The one that I see over and over and over at customers is on-prem Exchange, on-prem Lync, moving those Exchange mailboxes to the cloud. I see very few customers who want to have Lync online with Exchange on-prem. Right? And I see very few customers who want to have Lync online and Exchange online with call answering. Will we get there? Yeah, but right now, until we have full PSTN integration, Lync online is a presence and conferencing play. It's not really a telephony play. And so people who want call answering typically don't do that. So this requires a couple of things that you may not have thought of or that you may not have run across in on-premises deployments. The big one is that you have to have what Lync calls a hosted voicemail policy. This is just an object that tells Lync that voicemail calls should be routed to some external organization. Now, to make that work, there's also an application. Remember, I mentioned the Exchange routing app that runs as part of Lync 2013. You have to also spend a little tiny bit of time configuring that. But before you can do that, we have to discuss the value of this MSXUC voicemail settings attribute. What a great name, right? They should just throw pro in there and we'd be all set. This attribute on a user account indicates whether that particular user is enabled for hosted voicemail or not. So think about this as the user can be enabled or not. If they are enabled, they can be enabled for on-prem or they can be enabled for hosted Both of those have to be set if you want a enabled user to be able to use hosted voicemail. So they've got to be enabled and they have to have this attribute set to a value that indicates that the call can be handled by the hosted voicemail system. This is what gets you the case where you've got on-prem Exchange answering calls for some users and hosted Exchange answering calls for others. Because this attribute is what controls where Lync sends the call, to the on-prem or to the hosted Now, notice what I said as the last bullet on that previous slide. The hosted voicemail policy still controls where the call actually goes when Lync decides that that user is enabled for hosted voicemail. So, just like with almost every other kind of Lync policy, you can use the global policy and change it and have it automatically apply to everybody, or you can set site or per user policies. Okay, which one of those you use is going to be completely up to you based on what you're trying to accomplish. The policy only has two things in it. It's really simple. It has the FQDN of the server, the Exchange Client Access Server that's receiving calls, and it has the name of your tenant. So for Office 365, right, is anybody here using hosted Exchange that's not on Office 365? I guess I should ask, is anybody here using Office 365? Is anybody in here ready to move to Office 365 so Microsoft will quit twisting your arm about it? Okay. So if you're using a different hosted provider, these values may be different, but at least for Office 365, the FQDN target is always going to be xap.um.outlook.com, and the organization name is always going to be the name of your tenant. So for my test tenant, it's worldsbiggeststartup.com. For your tenant, it may be tailspintoys.com or emia.contoso.com or whatever. So you'll use new CS hosted voicemail policy to create this policy that specifies these two things, and then you'll grant it either globally or at the site or per user levels. High-level process, and the only reason I'm not going into more detail on this is because I have less than 3 minutes before you all run out of here to go get ice cream, but also because this is something that's covered in more detail in the Lync hybrid deep dive session that's being presented separately. You have to configure your server to enable federation, which most of you probably have already done for IM and Presence federation. You have to create a hosted voicemail policy. You have to enable your Lync users for hosted voicemail. Remember, that's separate from you enabling them in the first place. And then this last step, I mentioned earlier that there's a script that you use in Lync for managing automated attendance stuff that goes along with xucutil. There is, and when you run it, it's going to create a contact object for every automated attendant that can receive calls so that Lync can route calls to those endpoints. You can do that using the script, or you can do it yourself using, and the commandlet name is escaping me, but I think it's new CS hosted contact. Okay, it's new CS something contact. When you do that, what you're doing is you're creating a contact entry in Lync that says, hey, if you have a call for this automated attendant or this subscriber access endpoint, here's where to send it. Okay, as if that wasn't enough. And remember, the presentation will be available online at my link in the next 48 hours, so don't worry about writing these URLs all down or trying to capture them in pictures. The ELO blog post, as I said before, this is the only public source of scalability information right now, and it says basically nothing. I like the performance guys. Jeff and his team work really hard to give us good performance guidance. There just isn't any for UM right now. The TechNet docs on how the Exchange routing app work in Lync are actually pretty interesting. They go over in more detail the steps of the high-level process I just outlined, as do these docs on setting up hybrid Lync and Exchange environments. Okay, related sessions. If you hurry, you can catch the Lync Online Hybrid Deep Dive. The archiving session is at the same time. If you have to pick between those, that's the hard part about Lync Conference, right? At pretty much every session slot, there are 3 or 4 good sessions. I'm doing a repeat of Better Together. If you wanted to know about archiving or about high-res photos or the Unified Contact Store, the other stuff that's in the 2013 products that doesn't have anything to do with that's where I'm going to be talking about those. Coincidentally, that's also this afternoon at 4:30. Buy my book, My Children Are Hungry. Please fill out your evaluations. Jamie has really been beating up the speakers to make sure that we remind people to fill out the evals.